Okay, we're now going to add a couple of algebraic fractions. We'll add two algebraic fractions, then we'll do a subtraction as well. And you end up with the quadratics on the bottom. So I'm just going to use the same process and just run you through a couple of things you definitely should do and a couple that you down to one thing absolutely that you should not do. So we'll start with a fairly simple one. 1 over x plus 3, x plus 3 plus 1 over x plus 2. Okay, so like that, we're going to use what should be a familiar method. We're just going to multiply this leading by diagonal. So that will be 1 times x plus 2, 1 times x plus 2. Now in practice, you probably know that 1 times x plus 2 is just x plus 2, but it's good to get the process down, especially when there's some brackets. Plus 1 times x plus 3 over, and then we have x plus 3 times x plus 2. So I'm going to write it like this: x plus 3, x plus 2. So it equals x plus 2 plus x plus 3 over. Now this is really, really important. Do not expand the denominator unless you have a good reason to do so. The reason might be because this is part of an equation. So if this had said 1 over x plus 3 plus 1 over x plus 2 equals a number, absolutely you would need to expand this denominator, or if for some other reason the question asked you to. Otherwise, don't do it. You will get no credit for doing this. I'm not saying you'll necessarily lose marks, but it's quite a lot of work expanding and simplifying this denominator if you don't have to. So it's over x plus 3, x plus 2. I'm just going to leave it like that. What I am going to do is collect the terms on the top, on the numerator. You should absolutely always do that. Simplify the numerator as much as you can, but do not expand the denominator. So this is x plus x is 2x, 2 plus 3 is 5, so that's 2x plus 5 over x plus 3, x plus 2. I think that the reason for this, it probably comes from applications really. You don't need to know about this at this stage, but when you go on to draw graphs of these things or use them, it's far more useful if the denominator is factorized, finding things like asymptotes, which you also don't need to know about just yet. Right, another example, we'll make sure we don't have ones at the top, and we're going to do a subtraction. So let's say 3 over x plus 4, x plus 4 minus 5 over x plus 5. Okay, so exactly the same approach. We're going to say this is 3 times x plus 5. So 3 bracket x plus 5 minus, because that's a minus sign, 5 times x plus 4 all over x plus 4, x plus 5. Okay, remember we are not going to expand the bottom, we're not going to do anything with it, but we absolutely are going to expand the top. So we've got some simple linear brackets to expand in this manner. So that would be 3 times x, 3x plus 3 times 15, plus 3 times 5 is 15. And you've got, I might just draw it just to make this obvious. A lot of people make the mistake here, they forget this minus bit. You have minus 5 times x is minus 5x, and then you've got minus 5 times plus 4 is minus 20. In an exam, you will often see, I'll just write this down first, x plus 5. You will often see a last negative here and a negative here, and often people forget, they don't notice that this number would be positive if you had a negative times a negative, because they forget about this. Right, so I need to tidy up the numerator, so I'm just collecting like terms. 3x minus 5x is minus 2x. 15 minus 20 is minus 5, all over x plus 4, x plus 5. So now it's up to you. That's probably good enough for full marks, but if it was me, I don't really like that, so I would pull a minus out. I might say equals minus 2x plus 5 over x plus 4, x plus 5. Okay, I'd probably leave it like that, but this would be just as valid as well in nearly every case. Okay, we're just going to do one tricky example just to show you what it can lead to. So 4x over x squared plus 6x minus 7 plus 9 over x squared plus 8x plus 7. So with this, you have to factorize those numerators before you can do anything. So you cannot possibly see a common denominator, and you definitely don't want to be multiplying these two together and just writing it like that. You're going to have to factorize them anyway. So what I was saying before, leave these things in factorized form. If they're in this unfactorized form and you multiply two together, you really do need to factorize. So the first thing I'm going to do is attempt to factorize both of those denominators. So this is 4x over, so x squared plus 6x minus 7, which is going to be xx. Simple sum and product factorization. The factors of 7 is a prime number, so it's got to be 1 and 7. 1 and 7, just have to get the signs. They multiply to make minus 7, so they're different signs. They add to make plus 6, so the biggest number must be positive. So plus 7 minus 1 plus 9 over, and then we have x squared plus 8x plus 7 is again going to be x and x. And we've got another 7. So 7's again only got two factors, it's a prime number. They multiply to make a positive, so they both have the same sign, but because this is positive as well, they both must be positive. So it's plus 7 plus 1. Plus 1. So now we can proceed to start to cross multiply like this. Do this sort of diagonal approach. So equals 4x times x plus 7 x plus 1 plus 9 times this one, x minus 1, x plus 7, all over, and now we need to times all of these. I'm just going to write them. So it's x minus 1, x plus 7, another x plus 7, and an x plus 1. So now you might have a look at this because everything's quite nicely factorized, and you might notice you have an x plus 7 in all through. So I've got one term on the top, another one, so two terms on the top separated by this plus sign, and then on the bottom it's fully factorized, just this times this times this times this. So I have an x plus 7 in all three terms, so I'm actually going to divide through. I'm actually going to cancel that off. So 1, 1, 1. That should make things a bit easier. And actually we could have avoided having to do that if we'd have used the other option to begin with, where when we got here, instead of doing this cross multiplication, we could have said, well, the common denominator is going to be x minus 1, x plus 7, x plus 1. Then we'd have just had to multiply this one through by x minus 1 times x minus 1, and this one through by x plus 1 over x plus 1. But anyway, we're now ready to do the next bit. So we're going to say this is 4x times x plus 1. So we multiply that out like a bracket, but it is a bracket. So it's going to be 4x times x is 4x squared. And you've got 4x times plus 1 is plus 4x. And then you have 9 times x minus 1, because the x plus 7 is gone. So that's 9x minus 9. So plus 9x minus 9. On the bottom, remember, I just leave it, but I've only got x minus 1, x plus 7, x plus 1. Okay, so I need to tidy up the top. Not too much to do with it. I'm just going to group the x terms. So plus 4x plus 9x is plus 13x. So this is going to be 4x squared plus 13x minus 9 over x minus 1, x plus 7, x plus 1. Right, and I'm not even going to look to see if the top factorizes, because I don't need to leave the numerator in a factorized form. I absolutely need to leave the denominator in a factorized form, but I'm just going to leave the numerator like that. So this is quite complicated, and you're unfortunate if you get one with this much working. But the process is factorize the denominators first and then go from there. So either with this generic approach, and then you might have to identify some common factors. Just think, if I hadn't have done that with the x plus 7, we would have had big quadratics on our hands. It would have cancelled anyway, I guess, but it would have just been a lot more work on the expanding front.